Solid principles are some basic principles of object oriented programming that can really help you when you're designing your applications and maintaining your applications. If you can remind yourself of these principles, you'll save a lot of headaches for yourself in the coming years. Solid principles are five basic principles, one for each letter in solid, and they're intended to enhance dependability and maintainability by basically simplifying things, decoupling things, and lowering the overall complexity of an application, and in particular, the classes that comprise the application. Robert C. Martin is the first one who's credited with coming up with these principles, and you can see that link where you can get the original paper, which is over a decade old at this point. He's also written a couple of books on agile development. So what is solid? These are the five principles. The first is single responsibility, and we're going to be talking about each one of these principles in detail. The second is open-closed principle. The third, the Liskov substitution. The I stands for interface segregation, and the D stands for dependency inversion. Single responsibility, in my opinion, is probably the most basic of the principles. It's also likely the most important, and probably the one that gets violated the most. It simply states that a class should have a single responsibility. That responsibility should be entirely encapsulated by the class, and all of the services of the class should be narrowly aligned with that responsibility. So what does that really mean? What that means is when we're creating a class, we only want it to do one thing. We want it to do that thing completely, and we don't want it to do anything else. And this is where it gets really hard, because as time goes by, we often add these little features that add to the class, but they don't quite fit with the rest of the class's original responsibility. So the class expands in terms of its responsibility, and also it correspondingly expands in its complexity. We're going to talk about expanding classes in another principle, but it does feed back to the idea of a single responsibility. So for example, we have a customer class, and our customer class is going to be your basic data layer business object kind of class. It's going to interact with the database for creating, reading, updating, and deleting. Basic CRUD operations. So that's what it should do. It should present that interface and just that interface. It should not in turn manage customer orders. Should not be doing any kind of operations for orders, querying for orders. That's not the responsibility of the customer class. It should also not provide helpful user interface methods. It certainly should not be outputting HTML that gets sent out to a web page as a way of helping things along. That's another class. And it should also not log exceptions. Now, this is a little bit interesting. You might say, well, it needs to handle exceptions, which is absolutely true, but it should not be doing the logging. It should communicate with a logger class to do that sort of exception logging. Again, the customer class has a single responsibility, and it should be focused on that responsibility. The next principle is the open-closed principle. And this is somewhat related to the single responsibility. It just kind of takes it through time. The open-closed principle says that software entities, classes, modules, functions, whatever, should be open for extension, but closed for modification. What that means is that we should be able to extend our entities, but we shouldn't be modifying them. And the best example we have in C# is inheritance. When we create a class, we want to extend it by using inheritance. We don't want to modify it to add features. So we want to allow its behavior to be extended without modifying the source code. So we do have to think when we construct the class, what should be public, what should be protected, and what should be private, in order to help with extension, but not go too far. They nicely allow us to do modifications to correct errors. That's a good thing. However, any new or changed features are going to require a new class. We don't want any feature creep in our original class, and we can create those new classes by inheriting from the original class. A lot of times, by the way, we'll talk about these principles in terms of how we violate them. I've tried to balance that with how we can actually work within them, but so often we're really talking about don't do this as opposed to do this. So we're going to have our user class, and this is one of those don't do's. And the user class supports multiple user types. There's an admin user, member user, and guest user. And you can imagine there's going to be a public property or something like that to set the user class type. And the behavior, of course, is going to be a little bit different for each type of user. They may support different views, they may have different roles or permissions, but it'll be a little bit different depending upon the type of user. You may well imagine then, in a get of a property, that there may be an if statement or a switch statement, depending upon what the user type is, whether it be admin, member, or guest. And the output of that get routine is going to be different depending upon the user type. So what happens if we add a user type? We have to change code in the class. We'll be adding a feature and we're changing code in the base class. So that's a violation of the open-closed principle, in particular, the closed portion of that. So instead, each one of our user types should actually be a class unto itself, and they should inherit from a user-based class. So I'll have that user-based class, it'll be all closed up. An admin class will have responses that are appropriate for admin, a member will have appropriate responses and methods for members, and a guest will have their appropriate responses. So we won't use just one class. If we need a new user type, then we just create a new class that inherits from the user-based class. So that's enough for right now. We'll take a break and we'll come back with Liskov substitution principle.